Hello students, next we are going to talk about the scope of indexing. So in the last session what you have learnt, so what are the phases you are going to do in all the documentation to the indexing part. Now why we need this particular indexing and what is the scope of this particular indexing. So as I said previously, we used to have indexing manually, but imagine the information what we are using and how much information you are getting and how much we are searching nowadays, we cannot be done manually. So this have to be done automatically, and indexing is more important in this context. Second one, we should know all the vocabulary domain. So it may be depending upon the author or the indexing. Suppose if I take any language, English, the vocabulary will be different, the French it will be different. Okay, so in this part we won't depend on the vocabulary, only we'll go with whatever elements or whatever the search keywords you have. Next one is we have to check the different testing quality of your levels of indexing. Okay, so whatever the indexing qualities we are going to use. So I should not say that I am searching for a keyword called bat. So it is not properly giving. So I should not say that indexing problem was arised. So this have to be done. Next one, we should know when you have to stop the indexing process. So when you get the complete document, right? We are starting with the document and end of the process you are going for the indexing. And when this process have to be stopped. So we have to mention clearly. And what are the two factors to decide on level of indexing an item? So first factor is according to your relevancy. Second one is what is your weightage. So what is your weightage? So these two things you have to mention, and how the specific indexing have to be decided. Suppose if I am a client, I mention that my indexing should be like your serial number, keyword, and what is your weightage. So what is your weightage of your word? So this will depends upon your how the specific indexing and exhaustively have to be done according to the desire of the client. So next one, if for example if you take a 10-page item on a microprocessor, so how it will discuss on onboard cache and should be concept indexed. So what is the meaning of this over here is, so I have a 10-page item. So I only want about the whatever the onboard caches are available. So how it have to be indexed. So what I can do here, I'll only take two keywords. One is onboard and I'll use caches. Okay, so these two will be helpful in your scope of indexing. And how it will be related to your indexing terms used in the indexing. How I have to write these terms, because when I'm drawing in the search engine, how oftenly I use the word. I can use board. Okay, I can use only on, BOA. If you check the Google server, whenever you are typing the letters, automatically it will give all the elements related to this one. So this have to be mentioned here. For example, I'm talking about the processor, or it may be a microcomputer, or it may be a Pentium. So all these are related to your processor, right? So when I click on this processor or microcomputer or Pentium, it should be of same relevant, right? All belongs to only one concept. So when I'm searching this, it should give all the elements related to three values. It should not say that Pentium is not processor, because we are not searching on the concept of keyword, right? We are searching on the concept of concept, what you are going to do. So next, most important thing you have to remember here is how to use your general index time in order to exhaustively and specifically low. Means suppose as I said we have processor. So in place of processor it may be a Pentium or Intel. So what is a generalized word, this Pentium or Intel processor? So I have to use this keyword. Instead of writing instead of writing Pentium or Intel, whenever I click, I will type as processor, it should redirect to type of processor available in your database. Okay. So next point, we have to always index with the simplest case. So it should not be complicated. So whatever the terminology you are using, we have to use very simple, not complicated and irrelevant to your subject. But sometimes it will go for loss of precision and recall. What is precision? You may have irrelevant data, but recall, you should not have irrelevant data. So if you go with the general indexing, it may result in loss of precision and recall. So next one is preordination and linkages. So before starting preordination, I want to just tell you what is meant by linkage. Yeah. Suppose if I am taking one keyword. Okay, I am doing the keyword search. I am taking one first word. So you'll have the first word which is linked with the second word. Please try to understand this thing. So when I am doing the indexing, I have not linked this first word with the second word. Okay, so this have to be done while doing the indexing. Okay, simple example I'll tell you. I'm writing processor. First I didn't map it with Intel. So whenever I'm typing processor, only the information related to process will be displayed. Suppose I know that Intel is also part of the processor, so I have to do this linkage with the processor. So this is exactly available between index terms. Okay, so you have to identify if I have term 1, index 1, comma index 2. So if these two are linked, so this linkage have to be mentioned while doing in the indexing only. So this is called as linkages. Okay, you can also use correlate attributes. So as I said, processor is related to, like Intel is related to the processor. Similarly, I'll have Pentium. It is also related to processor. Now what these two becomes correlated? Intel, comma Pentium belongs to the same group. So these are correlated. So this process is called preordination. So what is preordination? If two elements are of the same branch or of the same domain, you have to coordinate these two. This is called as pre-coordination. Okay. Suppose if these are not coordinated, so then what happens? Your time complexity of this particular will be more. Why? Because what I'll do, I'll type the processor in the search engine. I'm not mapped with the Intel. So what it will do? It will want to specify this Intel. So it will only specify your processor called Pentium. Then what I do? Instead of this processor, I want to check with the Intel. Again, I'll type the keyword called Intel. So this particular search time, overall search time will be more. Okay. So that's why preordination and linkages should be specified in the indexing. And this process of coordination using AND, okay, 1 second. Now, what is this AND here is, what I'll do, I have not mapped Intel and Pentium. So what I'll do at the time of indexing, I'll add these two with the using of AND operation. Okay. So using this particular ANDing, I am combining these two, which is called as post coordination. Okay. So preordination means it will be done at the indexing time. Okay. Post ordination means while searching you have to mention. So you have to AND the indexing terms. So for example, we have so many linkage processes are there. One of the example is Mexico by Citgo and introduction to oil. This was one of the item discussed in as an example. So please go through with this. So next one is data structure. So before starting this one, I just want to, yeah. So please listen here. So we'll have the document. Okay, document may be text or image or video or anything. After that, what we are doing? Parsing. Okay, next we are going for lexical. Then you are going for stemming. Okay, I hope we have done with the indexing. Now what we are going to do? Okay, so before doing this indexing, you should have data in some specific format where you are going to store this data indexed. Okay, so this is called as data structure. So you know all the data structures, you have learned all the data structures. So I have to convert all these terms, text, image or video or audio, into a specific data structure in order to do proper indexing. So this is a role of the data structure, and which is very, very important for the retrieval system. So what it is going to do? So it will have a set of associated capabilities. So if I am talking about linked list, you know very well how the data will be stored and how to represent the concept, means how you are going to store data in this particular data structure, and it will also support the location of that particular content available in that. Okay, so what are the basic data structure in your IRS? So first one data structure is for store and manages, and the other data structure is for processing the tokens. Okay, so if you have the data structure, first one it will only store the data. Okay, next one it will only for processing, or you have to check with the support system like a retrieval system. So these two have to be interlinked. So when I am entering the keyword, this will be checking or processing, and it will retrieve the data from the stored one. Yeah, so this is your complete structure. First you'll get the item, you have to go for the item normalization, then you'll create files, and each file will have document manager, and document manager will have all the original document files, and this will have the processing token. So here original document file will store the data, and this will connect it to this in order to get the data. So this is a basic data structure used for retrieval system, not like our stack queue. Okay, so this is the basic data structure. Okay, so what are the basic things you have to remember? First one is you have to focus on the data structure. Second, you have to focus on the stemming. So what is stemming? As we have learned, stemming will be removing unnecessary data from your data structure. So for example, process, concept of word, whatever the canonical language or whatever the words, you have to remove those particular words, and you have to mention only one categorized accepted morphological terms. And this is this process may decrease in the performance, but advantage is it will increase the recall, means it will won't take the irrelevant information at all. So what are the different stemming algorithms? What you are going to do in the stemming algorithms? First you have to remove all the ending part of your values. For example, so connect is the original word, you are removing ed, you are removing ing, you are removing ion, and you will remove all the ions. So this is called as the stemming part. So we have to remove all the suffixes, and finally you have to go with the connect. And what is the data structure you are going to store? Connect is the keyword you are going to store. So what are the basic uses of this one? So you will have the categories according to that, and you will have the proper names for this particular thing, and it will also helpful in your natural language processing system in order to check the data properly and retrieve exactly. Yeah, thank you.